Hi, I'm Professor Mehmet Engin. Today's seminar topic is self-detection of early breast cancer with infrared camera and deep learning. This seminar is based on the related original research papers. Now, this is outline of the seminar. Firstly, motivation and introduction. Next one, materials and methods, that including the subtitles, framework, deep learning, graphical user interface environment, cloud computing, smartphone health applications, experimental setup, and finally, results and discussion and conclusions. Now, motivation and introduction. The new smartphone technology has become a strong competitor to computers. It is considered as one of the portable computers characterized by the characteristics of communication and service application for the user. This increasing growth in mobile applications in health care lead to huge number of applications. In 1916, there was about 600 applications for breast cancer awareness, screening, diagnosis, treatment, and managing disease. Mobile phone applications in the modern era carry many advantages that have become part of daily life. Due to multiplicity of these applications, it has entered the medical field, especially in breast cancer detection. Therefore, many recent studies indicate the culture of the finding solutions for early detection and prevention of breast cancer. Previous studies in early breast cancer diagnosis have not ventured into the use of the inspection of family of deep learning algorithms. Here, the proposed system introduced using the following deep learning models such as inspection v3, inspection v4, and modified version, the inspection v4. Further, previous studies indicate the lack of home diagnostics tools for early breast cancer detection. For example, it is noted that mobile phone application collect images using the thermal camera and transmits image to machine learning code running on an FPGA card nearby using a Bluetooth connection. However, such solutions may introduce low accuracy levels. In this study, the proposed system introduced user inspection v3, inspection v4, and a modified inspection MV4 with very high accuracy and efficiency, allowing for early detection of breast cancer at an early stage, and helps conduct regular and continuous examination follows up without violating the privacy of the patients or introducing any side effects. Now, materials and methods. The breast cancer screening scheme is presented using a mobile application, shortly app, connected to the thermal camera. Outline at beginning and describe each process in detail. First one, framework. Figure 1 illustrate the proposed approach for breast cancer screening using a mobile app. It can summarize as follows. First, training the deep convolutional neural networks as a model inspection and V4. Second, creating a graphical user interface development environment GUID in MATLAB using visual elements such as icons, buttons, scroll bars, windows, and boxes to simplify the interaction between the human and the computer. Thirdly, using cloud computing for the intense computational requirements and large data processing found in a deep convolutional neural networks. Fourth, using the mobile application to send thermal images for cloud computing, receive diagnostic results, and display on user's smartphone screen. Moreover, a set of thermal images were sent from the smartphone for cloud computing on different distances and methods to verify the quality of the image as shown in Figure 2. For effects on the thermal image, namely blurring, shaking, tilting, and flipping, were added to verify detection accuracy. Now, about of deep learning in MATLAB. Deep learning is a branch of machine learning that uses deep convolutional neural networks to extract features directly from a database or data. Therefore, it achieves advanced classification accuracy that exceeds human performance. Deep convolutional neural network training requires sets of databases that includes thermal images of healthy and breast cancer. Breast thermal images were downloaded from the dynamic thermogram, DMR-IR dataset, and deep convolutional neural network model inspection, MV4, was loaded. The learning rate setting was adjusted and optimization method was chosen. Database is divided into 70% for training and 30% for testing and train the deep convolutional neural network inspection, MV4, as shown Figure 3. Smartphone applications or app employs developed deep learning algorithms, namely inspection V3, inspection V4, and modified inspection MV4. The deep convolutional neural network modified inspection MV4 was developed for higher detection accuracy and faster arithmetic operations compared to inspection V3 and inspection V4. The major change in MV4 is the number of layers in inspection B is less than those of inspection V4. Table 1 shows a comparison between deep convolutional neural networks inspection V3, inspection V4, and inspection MV4. Finally, all size of filters used in these neural models 2 times 2 and 1 times 1 with average pooling and max pooling. Now, the graphical user interface development environment, GUID. The advantage of graphical user interface is the availability to users who does not know MATLAB or other programming languages. The graphic user interface is created using a set of icons such as buttons, scroll bars, windows, and boxes to simplify it for the user. A graphic user interface was created in Figure 4. Which contains a dedicated place for displaying the thermal image and showing the diagnostic results. In addition, auxiliary icons for diagnosis have been created, such as the patient's name, age, gender, and room temperatures. Now, the cloud computing. Cloud computing can process large volumes of data with low cost, high performance, and unlimited storage. In addition, it is possible to add a set of GPUs with high specifications in cloud computing. The PC was used as a cloud computing platform where thermal images were received from the smartphone and processed on the PC, and the results then were sent to the smartphone via the applications as shown in Figure 5. Now, smartphone health application. Mobile health is an application that provides healthcare via mobile devices. It has been popular in recent times due to people's interest in public health. Some health applications rely on periodic monitoring and are usually connected to sensors to collect data such as heart rate and track the exact geographical location. Therefore, these applications provide new solution for digital health services. Previous studies have indicated solutions to breast cancer recurrence and prevention, but no primary diagnostic aid for breast cancer has been mentioned. By adding a thermal camera with smartphone applications, it is possible early detection of breast cancer. Now, experimental setup. As shown in Figure 1 earlier, the steps for implementing early detection of breast cancer scheme using a smartphone application that is equipped with thermal camera. The used PC has namely Core i7 RAM 36 GB and GTX 1660 GPU with 6 GB RAM and MATLAB version 2020A and DMR-IR database and Huawei smartphone, Fuller Pro 1 thermal camera, and AirDroid apps. In addition, a deep convolutional neural network is designed as inspection MV4. To train the deep convolutional neural network model inspection MV4, it is the learning rate approximately 10 to minus 4 and use the stochastic gradient descent with momentum SGDM optimization method. After training the deep convolutional neural network model inspection MV4 and verifying a set of tests, it is transferred to MATLAB's GUID. The user interface is designed in two parts. The first icon contains the thermal image and the other contains the diagnostic results. The AirDroid applications was installed on the smartphone and on the desktop to insert thermal images from the smartphone into the cloud computing and send the diagnostic results from the cloud server to smartphone again. In conclusion, a group of thermal images captured by the smartphone was tested by the thermal camera, namely Model Fuller 1 Pro. A comparison of the performance of 3 deep learning algorithms implemented on the app or application is shown in Table 1 as shown earlier. On the other hand, experiments were made as follows, where the sources of thermal images were used. The first source was DMR-IR database, and the second source was the Fuller 1 Pro connected to smartphone device. The first experiment used 6 thermal images from database, including 3 healthy images and 3 breast cancer images. The second experiment used 5 thermal images taken by the Fuller Pro 1 thermal camera, all of them were suffering from breast cancer. To verify factors affecting the quality of thermal images, they were sent from the smartphone to cloud in different ways. The first stage, thermal images were sent from the database and from Fuller 1 pro-thermal camera to the cloud via Wi-Fi and different scenarios, namely 1 meter, 5 meter, and 7 meter, all without barriers. Second stage, thermal images were sent from the smartphone to cloud server via Wi-Fi with barriers between the smartphone and Wi-Fi, such as one wall, two walls, and roof, a roof with one wall, and roof with two walls. The third stage, thermal images were sent from the smartphone to the cloud server by cable. And fourth stage, thermal images were sent from the smartphone to the cloud server via the 4G network. The fifth stage, thermal images were compressed by different percentage values, such as 5%, 15%, and 26%, and sent from the smartphone to the cloud computing. In addition, 8 metrics were used to measure the quality of the thermal images received in cloud server, such as mean square error, MSE, peak signal to noise ratio, PSNR, average difference, AD, structural content, S3, normalized cross correlation, NK, maximum difference, MD, Laplacian mean squared error, LMSE, and normalized absolute error, NAE. Image blur occurs when the camera moves during the exposure. As for the thermal camera, when blurring occurs around the temperature grades, it may lead to incorrect readings in pixels and to unreliable results in thermal images. The researchers also studied the extent to which the blurring affects the accuracy of the breast cancer detection. Furthermore, the thermal image tilt is a common processing routine for training the deep convolutional neural network. The tilt depends on the angle and the point of the tilt. The goal of the blur, flip, and tilt is to increase network training and achieve the best diagnostic outcome. In addition, the increasing acquisition of thermal images by inexperienced users lead to a large number of distortions, including shaking, image caused by the camera shake. However, 4 factors have been added to influence the accuracy of the thermal imaging diagnostics, such as blurry images, flipped images, tilt images, and shaken images. Finally, the accuracy of the diagnostic was verified in every aspect of the evaluation. Now, results and discussions. This is connected many experiments by applying the proposed method, and the results of the evaluation show the success of detecting breast cancer at an early stage. The Deep Convolutional Neural Network Model inspection MV4 showed excellent performance in the training phase, so the diagnostic accuracy reached 100%. Moreover, the diagnostic period is only 6 seconds from sending the image through the application and until receiving the diagnostic results and interface on the smartphone. The results show that the size of the application and user interface fees amount to 1.5 gigabyte due to their large database. In addition, the thermal image processing using deep convolutional neural network requires a high-speed GPU that is not available in smartphone. So cloud computing has the ability to quickly diagnose and send result to smartphone application. The results show that the thermal images, namely from the database and Fuller One Pro thermal camera, sent from smartphone to cloud computing server via Wi-Fi, either direct or with barriers, didn't change the quality. However, when compressing thermal images from the database and sent them from the smartphone to cloud, image quality changed some amount of changing. In addition, when thermal images were compressed by 5%, 15%, and 26%, the diagnostic accuracy changes with a very small differences of 0.0001% max with the change in quality of thermal images. As for the diagnostic accuracy of compressed, such as 5%, 15%, and 26%, thermal images used from the Fuller One Pro compressed the original images, it changed by the maximum differences of 0.1% with the change in quality of thermal images. In the second part of the experiment, the results indicated that the use of 4 factors affecting the accuracy of diagnostic fluctuated. The results of the experimental using thermal images from the database showed that detection accuracy in the first, the second, and the third health thermal images decreased by maximum of 1.6% in blurry images, tilted images, and shaken images. However, the flipped images has maintained 100% detection accuracy. As for the breast cancer thermography, detection accuracy increased by the blurry images and shaken images by 0.002% approximately, while diagnostic accuracy decreased by nearly 11% in tilted images. However, in the flipped image, the accuracy percentage remained the same in the original image. On the other hand, the result of the experiment in which Fuller One Pro thermal images were used when compressed and sent from the smartphone to the cloud computing server indicate a decrease in quality of thermal image sent. However, this change in the quality of thermal images affected the detection accuracy. As a result, showed a very slight fluctuation of detection accuracy percentage around 0.03% approximately. In addition, when blurry images, shaken images, and flipped images were used, detection accuracy has increased by a small percentage, about 0.4% maximum. But when using tilted images, the detection accuracy percentage fluctuates minus plus 0.5%. Now, conclusions. Health applications in smartphone contributed to the increase in the culture of self-care. Given previous studies that seek to reduce the incidence of breast cancer, however, it needs a primary diagnostic tool that is compatible with health applications in modern smartphones. This study proposes a home automated diagnostics tool with the help of smartphone applications, cloud computing, and thermal cameras. The experimental results confirm the effectiveness of proposal as the accuracy rate in the breast cancer detection has reached 100%. It is concluded that breast thermography using health applications for smartphone and cloud computing is a good tool for early detection of breast cancer, especially for remote areas and elderly patients, in addition to providing features related to health education, rapid response, and periodic follow-up for patients. This tool and the smartphone application makes a quantum leap in raising the efficiency of initial self-diagnosis. Moreover, this technology is characterized by repeated use at the same time and used as a family diagnostic tool. Additionally, results show that the quality of thermal images didn't affect by different distances and methods, except in one method, one compressing thermal images. The result indicate 1% as maximum detection accuracy when compressing thermal images. In addition, the results indicate detection accuracy increase in blurry images and shaken images, while diagnostic accuracy decreased by nearly 11% in tilted images. Future work could lead to creation of an integrated health application that includes health education, periodic follow-up, communication with the health center, care center, updating patient data, prescriptions, and exercise, in addition to using this technique to detect other diseases such as lung cancer and food ulcers. Moreover, future work should add a set of effects to thermal images before training in the deep convolutional neural network. Future work should focus on improving the classification and detection accuracies considering different age groups, gender types, and other convolved medical preconditions. Previous studies have ignored the diagnosis considering these important factors. An interesting fault diagnosis method that combines thermal imaging and machine learning. Future work may look into the possible application of this method to early detection of breast cancer. Thank you. See you again. Bye.